as moments of equilibrium, but this time around we're having the distributed load. The load is distributed for a span of 10 meters, and the distributed load is 1,000 Newton per meter. So we all know loads or weights are always measured in Newton. So what we have here is 1,000 Newton per meter. It's not load, but what a load distributed through a span of length of 10 meters. So the question says we should determine the reactions at the supports. Look at the question. We have two supports, support 1 and support 2. What is the reaction at the support? So to do that, distributed within the span of 10 meters. Remember, this load is uniformly distributed. We have various types of uniform distributed load. We have uniform varying load, uniform distributed load, among other types of distributions. But in this case, we are having uniform distributed load. So how do we get the actual load? The load now, or the weight, is now 1,000 Newton over meter. Newton per meter means Newton divided by meter times the span at which the load was distributed, which is 10 meters. So meter can cancel meter. We are just left with Newton, which is the actual unit of load. So if I use 1,000 to multiply 10, so the actual load distributed within the span of 10 meters is 10,000 Newton. But where am I going to position this load of 10,000 Newton within this span? Like we said, it's a uniformly distributed load. For a uniform beam, let's consider a rectangle. What is now the center of gravity of this? Center of gravity is this point. For a uniform beam or bar. So for a length of 10 meters, the center of gravity will be 5. You can see this weight is centralized at the middle of this rectangular box. So since it's uniform, this load of 10,000 will be situated at the midpoint of 10. And what's the midpoint of 10? Is 5 meters. Therefore, I need to redraw the free body diagram that shows the actual load and the position of center of gravity and the reactions at the support. So let's draw the free body diagram. A free body diagram is a diagram which shows all the external forces acting on a body or a particle. So since we have a reaction here, a support here, we are going to have a reaction. Let's call it R1. So you have a support of 10 meters. Like I said, it will be positioned at the center of gravity of 10. Center of gravity of 10, that is 5 meters. Here is now 10,000 Newton. That means the distance from here to here is 5 meters. The distance from here to here the load was distributed is 5 meters. So we also have the setting distance from here to here as 5 meters. Then we have a load of 20,000 Newton, while the last distance from here to here is also 5 meters. So this is now the free body diagram. It's, like I said earlier, it's a diagram which shows all the forces, all the external forces acting on a particle or a body. So we can label the figure if we choose to. So let me call it point A. Here this load is, let's call it point B. Here this load is, let's call it point C. And here this load is, let's call it point D. So we have to take moment either at point A or at point D. That decision is personal. So let's take moment. Taking moment at point A equals to 0. This is one of the conditions for equilibrium force system, where the sum of all moments acting at the point is equals to 0. Actually, we have 3 conditions for equilibrium force system. 1, total upward force equals to total downward force. And 2, sum of all moments acting at the point is 0. And 3, sum of clockwise moments must be equal to sum of anti-clockwise moments. So let's apply this first condition for equilibrium. Total upward force equals to total downward force. So from the figure, who are the upward forces? R1 and R2 are the upward forces. Who are the downward forces? 10,000 and 20,000. So how do we put that in statements? I will have summation f of y equals to 0. That is sum of all those acting upward are positive. If I sum all together, the result is 0. That is sum of all forces acting at the point is 0. So this is an upward force, therefore it becomes a positive force. R2 is also an upward force, it becomes a positive force. The force at point B is downward force, and since acting downward, That is negative force, 10,000. The force at point C is also acting downward. That is my negative also. That is 20,000 is equals to. So I can add these two guys. I'm having R1 plus R2 minus 30,000 is equals to 0. So let's make R1 and R2 the subject formula. R1 plus R2 is now 0 plus 30,000. By collecting like terms, I will divide this one here. R1 plus R2 is equals to 30,000 Newton. Let's call this equation 1. So let's apply the second condition by taking sum of moment acting at point A is equals to 0. That means this force here is acting to point A, this force to point A. And what is moment? M's represent moment. What is moment? Moment is force times perpendicular distance. So the force and distance comprises a moment. So at point B, this is the force. What is the distance of this force to point A? It's simply 5 meters. What's that the moment? It's 10,000 times 5. But while doing so, we consider the concept of clockwise and anti-clockwise. You can see this force is clockwise, this force is clockwise, while arrow is moving in anti-clockwise direction. So those acting clockwise is positive, while those acting anti-clockwise is negative. So let's apply that. So what's the moment of this force? It's 10,000 times 5. So I'm having 10,000 times 5. What's the moment of this force? This force is 20,000. What's that the distance from point C to point A? Is 15 meters. Because we're making A as our reference point. So everything must come to A. Times of 15 minus, because this force is moving in anti-clockwise direction. Arrow 2 is moving in anti-clockwise direction. So what is the distance of arrow 2 to the reference point A? Is 20 meters. So I'm having arrow 2 times 20, the value equals to 0. Because this principle says sum of moment acting at a point is 0. So let's simplify what we have. 10,000 times 5, that will give us 50,000 plus 20,000 times 15, that will give us 300,000 minus arrow 2 times 20, that will give us 20 arrow 2 equals to 0. So I can add these two guys together, 300,000 plus 50,000, that will give us 350,000 minus 20 arrow 2 equals to 0. So let's make 20 arrow 2 the subject formula. So by collecting like terms, I will invite 20 equals to 350,000. So 0 plus anything is that thing. So 0 plus anything, 20 arrow 2 equals to 350,000. Therefore, my arrow 2 is now 350,000 divided by 20. So arrow 2 give us what? Give us 100, that is 17,500 Newton. So we are looking for the reaction and the two supports. So what from equation 1, from 1, we have arrow 1 plus arrow 2 is equals to 30,000 Newton. What is the value of arrow 2? 17,500. So I'm having arrow 1 plus 17,500 is equals to 30,000. Therefore, my arrow 1 is now 30,000 minus 17,500. Arrow 1 will give us 12,500 Newton. So the reaction at both supports is reaction 1 is 12,500 Newton, reaction 2 is 17,500 Newton. So this is how to apply the concept of moment, uniformly distributed loads, and the concept of equilibrium force system. So if you have any question, you can also put it at the comment section. Like, subscribe, and comment. Thank you.